Hello again, and welcome to Get It Right, where we try to explain as easily as possible how to complete any and all mathematical problems. Today, we are going to discuss, by request, calculus, the derivative, and the number line test. And as always, we want to make it easy and get it right. Now, when it comes to calculus, we need to know some definitions. First off, calculus is the study of continuous change. How does something change? How does it increase, decrease? How does the change increase or decrease? This is something that ends up becoming very valuable in economics, very valuable in science, physics, chemistry, biology, physiology. There's many topics that will use calculus the farther along you get. Within calculus, since we're going to talk about just the basic part and do a specific item, we do need to make sure we know what a derivative is. The derivative is the rate of change of a function, otherwise known as the slope. Every function, every curve has a rate of change, has a derivative, and using that derivative, you can easily find a slope at a given point of time. Most people are used to slope of a line. However, when you get into calculus, you learn that you can find slopes of curves. And that's what we're looking at here. The next definition specific for this video is the number line test. It pretty much is what it says it is. It is a number line, so just one line with numbers. Everyone should remember what a number line looks like. And we are just breaking this down to its basic parts and using it to test intervals where a derivative of a curve, the slope of a curve, can be increasing or decreasing. But in order to do that, we always have to find the zeros. When does the slope equal 0? When is it not increasing? When is it not decreasing? When is the situation just remaining constant? So, while we're doing that, let's move on to the first question. This is one of the questions that was requested. For this question, it says, for the function given, find all x values where the derivative of f of x, f prime of x, is greater than 0. And the function is f of x equals x cubed minus 75x minus 6. So the first thing you do, read this question. It wants to know all the x values where the derivative is greater than 0. So where is the slope positive? Now, since this is not a line and it is a curve, it is a cubic function, these functions increase and decrease. They go up and they go down and they go up again. So we need to find out where this happens. Well, the first thing we are going to do is find the derivative of the function. We are going to assume that we have all been through the first sections of this, where you learned how to take limits of the function to find the derivative, and then eventually find the derivative using the actual rules and shortcuts. In this case, you take the exponent, drop it in front of the term, and decrease it by 1. And if it has no exponent, the variable disappears. If there's no variable, it's 0. So the derivative of our function is f prime of x equals 3x squared minus 75. Once we're there, find the zeros of the derivative. Find out where the slope is 0. So we set this derivative equal to 0 and solve it. Now we're doing algebra. Add 75 to both sides. 75 equals 3x squared. Divide both sides by 3, so 25 equals x squared. And then we will take the square root of both sides because we don't need x squared, we need x. And here comes a common mistake that a lot of people do. We know what the square root of 25 is, but the square root of x squared is actually the absolute value of x. We are introducing a square root, which means you have to look at both positive and negative versions of a number. So in algebra, if we're doing this step, we're saying, hey, square root of 25 is 5, but the variable is absolute value of it. Because there are two numbers that you can square to get 25. Positive 5 or negative 5. Negative 5 times negative 5 is 25. 5 times 5 is 25. So that means our zeros are going to be at x equals 5 or x equals negative 5. So now, once we found those zeros, we will take the time to do the number line test, because we need to know where this slope changes. When does it go up? When does it go down? When's it increasing, decreasing? So we create a number line, very basic number line, because all we need to worry about are the zeros. So we draw a number line, put a negative 5, obviously on the left side, positive 5 on the right side. Now you need to test numbers. Choose a number in each of the intervals, to the left a negative 5, in between the two zeros, and then to the right a negative 5, and see what values you get. And you are going to test them in the slope function, because that's where we need to know if it's positive or negative. So I'm going to test negative 6, 0, and 6. Those are numbers that are not our zeros. They will give us values. I substitute that in. Basic math calculations, I get 33 for negative 6. And I plug in 0, I get negative 75. When I substitute 6, again, 33. We square a number, it gets rid of the negative sign. So squaring a negative 6 gives you the same thing as squaring a 6. So here we have a negative 6. When we substitute that in, we get a positive answer. We plug in a 0, we get a negative answer. We plug in a positive 6, we get a positive answer. So what we do is we write above each of the areas in our number line what sign it gave us, plus, minus, plus. So now, all we need to do is write the intervals, where the slope is bigger than 0. So when you look at the number line, where are the only places where there's pluses? To the left of negative 5, to the right of positive 5. So that means our answer is the interval from negative infinity to negative 5, union 5 to infinity. Or, if your class hasn't used those intervals yet, x is less than negative 5 or x is greater than 5. And that's the solution. That's the answer to this question. So let's go ahead and look at one more, and we'll wrap this up. And then if you have questions, you could feel free to post in the comments. So here comes the other question. Very similar, but look closely at what it's asking. For the function given, find all x values where f prime of x is less than 0. So this time, it's a little different from the previous one. This wants to know where we get negative answers. So let's go through the steps. If you want to do this before I do, feel free to pause the video, work it out, and then come back. So first, find the derivative. That's going to be 3x squared minus 48. We have to find all the zeros. Where does the slope stop? Where is it constant? Where are we done increasing and decreasing? So set it equal to 0. Solve it. Add 48 to both sides. Divide by 3. Take the square root. Square root of 16 is 4. Square root of x squared is the absolute value of x. What two numbers are 4 away from 0? 4 and negative 4. Now what do we do? do the number line test. So we take the number line, put our -4 and our 4 in there, and now just test numbers. For consistency's sake, in this time, we are going to go ahead and use the -6, 0, and 6. Okay, this problem actually looks very close to the previous one, but when you're dealing with cubic functions, it's always going to be like that. As you get higher up, do a quartic or quintic, you will see that there will be more curves, more zeros in your derivative, so more intervals to look at. So we go through the test, and amazingly enough, not really, but it is, we have the same type of interval, plus, minus, plus. If we remember, this is going to happen every single time we have a cubic because the coefficient in front of it is a positive number. So it will always be positive minus positive. If there was a negative number in front of that x cubed, if it was a negative x cubed, all of these numbers would be, all of those signs would be reversed. It would be a minus plus minus. But now, let's focus on the problem. Where are the derivative less than 0? Well, that is in between -4 and 4. So it's the interval from -4 to 4, or -4 is less than x is less than 4. Simple. If you have any questions, feel free to ask. Other than that, thank you for watching. I hope you have a wonderful day, and I hope this has helped you understand how to do this part of calculus.